This is the office hours video for section 9, solving simultaneous equations. Now, solving simultaneous equations happens a lot in physics. It happens in other disciplines too. Anytime you have multiple bits of information and you want to put those bits of information together, you need to solve them simultaneously. So there's three main techniques. There's what's called the substitution technique, and there's the multiply and subtract technique, and then there's also forming a ratio. Forming a ratio is also known as proportional reasoning. Now, one issue you might run into when you're trying to combine two or more equations is, which of these three techniques do you want to use? Substitution always works, so that's a no-brainer. But substitution is long and tedious. The other two are easier. Multiply and subtract is easier than substitution, and forming a ratio is the easiest of them all. So one thing you might want to learn is how to determine which technique is best to use in the given situation. So I'm going to look at the two equations given in the Now You Try It exercise in section 9, and they look like this. So the first one is x squared plus y squared equals 13, and the second one is x minus y equals 1. So substitution will always work. I'm not going to talk about that. What about multiply and subtract? What you want to do is take one of the equations and multiply it by a number and then subtract it from the other equation. So let me write the second equation underneath like this. And so what I'd like to do is multiply that equation on the bottom, x minus y equals 1, by a number and then subtract. And I want to have something cancel. I either want to have the x's cancel or the y's cancel. But as you can see, there's no such number that'll do that. So the x squared and the x will never cancel, and neither will the y squared or the y. So multiply and subtract won't work. What about forming a ratio? So I could take the two equations and divide them by each other. So take the first one and take the second one and divide them like that. Now this is a true statement, but it doesn't really get us anywhere because there's no way that I can simplify what's on the left-hand side. Certainly the right-hand side is equal to 13, but there's no way to factor x squared plus y squared in the real number system. And there's no way to cancel that with the x minus y. So you're just stuck. So for this example, you would want to use the substitution technique. The other two wouldn't work. Now let's look at an example where multiply and subtract would work, but forming a ratio wouldn't. So I'm just going to draw a line like so. Look at some stuff over here. So let's look at maybe 2x minus y equals 5, and x plus y equals, let's say, 4. Well, now I hope that you can see multiply and subtract will work. In fact, we could just add these two equations together, or we could multiply the bottom one by -1 and subtract. Either way, if we did that, if I just go right ahead and add them, and by the way, multiply and subtract is the same as multiply and add, or divide and subtract, or divide and add. They're all the same. I just chose multiply and subtract because that's the most common one. But if I just go ahead and add these together, then 2x and x is 3x, and negative y and positive y is 0. and 5 and 4 is 9. And so if I divide both sides by 3, the 0 doesn't do anything. If I divide both sides by 3, I get x equals 3. And if I substitute that back in, let's say I take the bottom equation, solve it for y equals 4 minus x. If I put in 3 for x, then y is equal to 1. And I can check those answers. The top equation, 2 times 3 is 6, minus 1 is 5, that's true. And the bottom equation, 3 plus 1 is 4, that's true. So for a couple of equations such as these, multiply and subtract works pretty well. I'll put a check mark over here on the left side. Substitution always works. The question is, what about forming a ratio? So let's try that. So I'll take the left-hand sides and form ratios out of those. And the right-hand sides and form a ratio out of those. So, again, the right-hand side will simplify. It's 5 quarters, 1.25. But there's no way to simplify what's on the left. So again, we're stuck, just like we were before. So what's going on? I'm going to put an X up here next to forming a ratio again. So what's going on? Why in these situations does forming a ratio not work? And the answer is because of the addition and subtraction. So forming a ratio only works when everything in the equations that you're using is either multiplied or divided. So there's no addition or subtraction. And that's the only case in which forming a ratio might help combine the equations and solve them simultaneously. So this is something you really need to think about before you start trying to put equations together. You really need to think about which of the techniques you can use to get the job done. And you want to use forming a ratio whenever possible because it's the easiest. But it doesn't work in all the cases. So that's something I hope that you think about, is getting a feel for which technique works best in which situation. And the best way to do that is to just practice. So I think I'll leave that to you now. Go and make up some equations and practice combining them. So good luck.